So in terms of pH, I'm going to guess that A was the most basic, and then B is the most acidic.
You are almost correct.
Today we're making some roasted potatoes. We at Reactions were inspired by Kenji Lopez-Alt's recipe, but we kind of wanted to put our own spin on it. So today we're going to play around with pH and see how it affects potato consistency, and then decide which ones we like most.
Delicious roasted potatoes are all about the perfect texture. And today we're out to find it using chemistry. To get set up, I'm filling each of these pots with 4 cups, or a liter, of water. Lots of recipes call for boiling the potatoes until they're soft, but not cooked through, before throwing them in the oven. Potatoes are mostly made of water, followed by starch, which is made up of the polymers amylose and amylopectin. Amylose and amylopectin are found in packages called starch granules that you'll find throughout a potato. These starches actually serve as stored fuel for the potato plant, the leafy part that grows above ground. The texture of a cooked potato is at least partially related to how phosphorylated its amylopectins are. When a potato is boiled, the starch granules swell with water and the amylopectin will break free. Phosphorylated amylopectins will stick to each other and form a gel as they cool. This makes your potatoes kind of gummy, and that translates to them holding their shape. Red potatoes are a great example of this. They have very well phosphorylated amylopectin, which makes them perfect for a soup or a stew. On the other end of the spectrum are russet potatoes. They don't have well phosphorylated amylopectins, so when you boil them, they'll break apart more easily. You'll end up with a fluffier texture, which is perfect if you're trying to make mashed potatoes. We decided to go with Yukon Golds because they're a nice in-between. They'll keep their shape better than a russet potato, but they'll fall apart more easily than a red potato. With our potatoes picked out, it was time to experiment with texture. Our goal was soft on the inside, but not so soft that the roasted potatoes would fall apart, and then crispy on the outside. To try to make this happen, we played with pH. So how does pH affect potato texture? Well, we were surprised to learn that it's incredibly complicated. We talked with a bunch of experts across the globe, and as it turns out, there are a ton of things going on. So we're going to get into a few that our experts thought were important. First, let's talk about pectin. This is different from the amylopectin I mentioned earlier. Pectin in the space between plant cell walls acts like a glue that keeps the cells stuck together. Pectin is a polymer of repeating galacturonic acid molecules that are linked together by glycosidic bonds. At a lower pH, like if we add vinegar to our water, those polymer chains hold together well. At a higher pH, like if we add baking soda to our water, boop, those glycosidic bonds linking pectin together start to break down, which leaves you with a mushier potato. On top of that, a higher pH will also make pectin chains repel each other, creating a looser structure, giving you an even mushier potato. Another thing impacting texture are those phosphorylated amylopectins I mentioned earlier. When phosphoryl groups are added, the whole molecule becomes negatively charged. When you add a base like baking soda, even more negative ions are thrown into the mix, making the phosphorylated amylopectin chains repel each other, and your potato falls apart. In all of these cases, acidic water helps hold potatoes together, and basic water makes them fall apart. So we're going to try 5 different pHs to see which one gives us the best consistency for roasted potatoes.
I'm gonna go most acidic, less acidic, neutral, basic, most basic. I'm gonna add 3 tablespoons of vinegar to these 4 cups of water. All right, so testing pH. So we'll use pH strips, but these are pH strips that have never been in a lab. I'd say this is somewhere between a 5 and a 6, but I definitely want it to be a bit more acidic. So I'm gonna add a lot more vinegar. I'm actually going to add an entire cup of extra vinegar. Let's test this pH. Oh, that's definitely more orange already. Whew, that's brighter. That's gotta be somewhere around a 4.
So that was the most acidic one. Here's where the pH came out for the rest of them.
All right, so I'm gonna add 5 pieces of potato to each of these pots.
Normally you would boil the water first and then add potatoes.
I guess I cut more potato than I thought I did. Let's go 6.
But because we take our safety seriously, I wanted to make sure I didn't splash boiling water on myself.
7, let's do 7. Oh my gosh, perfect. We can do 8. So now I need someone to come label these for me because I don't wanna know which pot is which.
We're trying to be as scientifically accurate as possible, meaning I'll be blinded to which potatoes were boiled at what pH. It's very secretive, serious business.
Okay. I think this one. Oh, you're close.
Once you can push a fork through the boiled potato chunks without too much resistance, they're ready to go.
E is done. I'm gonna add 2 tablespoons of olive oil to each of these.
Here, we're coating the potatoes with oil and spreading around the starchy paste they get from boiling. This is important for the Maillard reaction, which we'll get back to in a second. If this were a recipe and not just an experiment to play with texture, you'd want to add your favorite spices and seasonings like garlic, rosemary, salt, and pepper. We're just here for the science, so we'll leave that part up to you. Roast the potatoes at 450 degrees Fahrenheit or 230 degrees Celsius. Leave them alone for about 20 minutes, then use a spatula to pry them up off the pan and give them a flip. Cook for another 20 minutes or so, pulling them out when they're a crispy golden brown. That color is thanks to the Maillard reaction, a very complicated, multi-step chemical reaction that breaks down the amino acids and sugars in the oil and starchy paste mix that we coated our potatoes with. This reaction will speed up at a higher pH and slow down at a lower pH. So our potatoes boiled in baking soda water should come out more brown.
Our potatoes are ready. So I'm gonna go through each treatment in order and see how they turned out. So I'm gonna grab one of these. Ooh, well, maybe I'll do it like this so as not to squash it. So this here is A. Ooh, that's nice. Let's see how it tastes. Crispy, but the inside is very, very soft. So that was A. I'm gonna try E now. Oh, this one's pretty perfect looking, actually, I must say. I think that E is still a little less mushy than A. So A is a bit more mushy. They're pretty similar, but I would prefer E. So now we're gonna go with D. So this is way harder. The other ones kind of fell apart. This did not. I feel like the outside is still, it's a little bit chewy. It's a little less crispy, but the inside is kind of perfect, I have to say. Let's try B. So this is definitely harder to cut through than D, and definitely a lot harder than E or A. It's a little weird. It's pretty hard on the outside, and even though once you get to the center it's soft, it's still a little bit too hard, I think, a little crunchy overall. Okay, final one, C. All right, that was way easier to cut through than B, and a little bit easier to cut through than D. I like that. So if I was gonna assign an award, I would give E the gold star, C would get the silver, and I think D or A would get the bronze, I can't decide. So in terms of pH, I'm going to guess that A was the most basic, E was slightly less basic than that, C was neutral, followed by D. D is a bit acidic, and then B is the most acidic.
You are almost correct.
What was I off on?
So E was the most basic.
Oh, okay. Huh. I really liked that. Was my favorite. Awesome. Throw some baking soda in your water when you make potatoes from now on.
The take-home message is, if you want what we think is the perfect roasted potato texture, lay on the baking soda when you boil. We were all actually shocked at how much baking soda we could use and still end up with delicious potatoes. So go forth and make some amazing potatoes. And let us know how they came out in the comments. We'll see you next week. If you're in the mood for more food science, be sure to check out Serving Up Science, the newest show in the PBS Digital Studios family. Serving Up Science is hosted by history buff, science writer, and foodie Cheryl Kirchenbaum, who will give you science-backed answers to all of your biggest food questions. What's better, wild or farmed salmon? Should you let your meat rest? What makes that blue cheese so stinky and delicious? Follow me over to the PBS Food channel to watch Serving Up Science, and tell them we sent you.